So here we have chain rule where we actually have three different functions here. So if I look at this closely, what's my outside function? Remember this square right here is really, it's a shorthand, but technically it's actually cosine of x to the fourth squared. That's what that square over the cosine means. It means I square that whole output of the cosine after it's already had the input. So my most outside function then would be that too. So the most outside function would be this, I'll do it in pink, this 2. This part would be the outside. And then I could cover up this cosine x to the fourth, but even if I look even deeper into that, I can see, oh, I can actually cover up the x to the fourth and still have a third function there. So my most outside function is the square. So I could use y equal to u squared, or, let's use g. No, let's use u, that's fine. And then my next function could be z equal to cosine w, and then, sorry, that would be a u. And then our next input would be w. Our most inside function is really x to the fourth. So if I plug in x to the fourth into that w, and then push that into the u, then I would get x to the fourth on the inside and put it into cosine, and that all squared. So that's it's really a composite of three functions. So it's going to look something like dy in terms of u times du in terms of w times dw in terms of x. So really we have chain rule twice. So how does this look? So let's do purple. Okay. So we're going to start from the outside and just do one step at a time. So one derivative, and then when we get to the chain rule derivative, we'll write it out as the derivative in derivative notation. So starting with the most outside, so that's the y to the 2 squared. So the derivative of y, this guy right here, is just 2u. So 2 times u, where my u is really cosine, everything that's in there. So cosine of x to the fourth, that's in terms of x. That's u in terms of x. And then I multiply that by the derivative of what I have on the inside. Now on my next line, this part's already done. There's no ddx there. So I've already done the calculus on that, so I'm not going to do anything to it, but it has to stick around for the ride because it has to be there in the end. So we're going to keep it there. And now I see a ddx, so now I know I have something I need to evaluate. So that's cosine of x to the fourth. So my most outside function is the cosine. So I'll take the negative sign of the inside function times the derivative of the inside function. Okay, next line. Again, I don't have to do anything else to that first term or first factor because it's already done. The second factor is now, this is also already done now. I've already done that, so I can do negative sine x to the fourth. Nothing else to do there calculus-wise. Oh, now I have a ddx. That means I got something to do, and I'll take the derivative of x to the fourth, which is 4x cubed. All right, so I actually don't have any more calculus to do. There's no more ddx's. So we're done with the calculus. And now we move on to just simplifying and making it look pretty. So I don't have to put a line there, but we'll just separate it like this. So my next step is to kind of bring the negative out in front, like this negative right here. Let's bring her out in front. And the 4x cubed, we can bring that out in front, multiply it with the 2. So I get a negative 8x cubed out in front. And then I'll have the cosine x to the 4th and sine x to the 4th. I already took the negative out in front, so I just have this left over now. I don't really need a parenthesis between those trig functions, just need that parenthesis around the x to the 4th, so I know the x to the 4th is included on the input. So that it doesn't matter if cosine or sine, which one comes first, but just bring that coefficient and the single x and the negative out in front. Okay, let's look at this one now. So my inside function, what can I cover up? That's this guy. So that's my u. So my u equals 3x squared minus 2x. And that means my y is tan of u. So my dy dx is the derivative of tangent, which is secant squared. Don't change the inside. And then multiply by the derivative of the inside in terms of x. Oops, sorry, not you. This time I had to put a bracket around the derivative because I got a binomial and I want to make sure I take the derivative of the whole thing. So the first term is already done, the secant squared. There's no more calculus left to be done there. I might try to simplify it at the end, but I'm done doing calculus there. Now I got my ddx, so ddx tells me I got to take the derivative of 3x squared minus 2, which gives me 6x minus 2. This is an important one where I have to have those parentheses. Don't forget those parentheses. On this one because I got the binomial there. What I'd like to do here, it looks really tempting again, just kind of like the one we did a little bit ago. It looks like I want to multiply. This is not multiplication between this and this. That multiplication is between this whole secant thing and that. So do not multiply. Do not multiply. This is not two binomials, polynomials. What we can do though is bring this out in front so it doesn't look like it should be multiplication. So we can bring that out in front. Oh, we still need the parentheses though because it's still a binomial, or we could distribute, but I think that would get kind of messy. So, but we don't need parentheses around the secant, but we do need parentheses around the input for the secant. So this is one factor where this part of the factor is an angle, and this is the second factor. So this really only has two factors, even though it looks like three pieces.